Back in 2017, a research paper came out of Google that pretty much lit the fuse for the AI explosion we're all living through right now. It didn't make a ton of noise at the time, but it built the engine that powers almost everything we call AI today. So today, we're going to tear into that very paper.
And it all kicked off with this wild, almost philosophical title, Attention is All You Need. I mean, what does that even mean, right? Well, it was a totally radical claim. It basically challenged the entire way we thought machines could understand language. And as we're about to see, it turned out to be so right.
So to really get why this was such a game changer, we have to rewind the clock to the before times, before 2017. Back then, AI models, like your classic recurrent neural networks, or RNNs, had to read language the way we do, one word at a time in a straight line.
Just imagine trying to understand a whole story by looking at it through a tiny keyhole, seeing only one word at a time. The poor model would have to remember the first word all the way until it got to the last one. The paper called this its inherently sequential nature, and honestly, it created a massive bottleneck. And because of this one word at a time problem, you had two huge issues. First, you couldn't really speed things up with more computing power, because you had to process word 1 before you could even start on word 2. Training was just painfully slow. And second, with long sentences, the model would start to forget what happened at the beginning by the time it got to the end. It was losing that crucial context. Something had to change.
Okay, so there was a glimmer of hope. An idea was already floating around called the attention mechanism. Now, this wasn't the big breakthrough itself, not yet, but it was a really important first step. Researchers started kind of bolting this feature onto those older sequential models. The idea here was to give the model a way to kind of look back and pay more attention to the most important words in the sentence, even if they were far away. It definitely helped with that context problem. But, it was still just a feature stuck onto a fundamentally slow, clunky architecture. It was a patch, not a total rewrite. And this is where the 2017 paper just flipped the whole table. The researchers at Google asked this incredibly bold question. What if the sequential part isn't something to fix? What if the sequential part is the problem? What if we just get rid of it and build a new model using only attention? What if attention really is all you need? And here it is. This is their solution. The transformer. This diagram is basically the blueprint for modern AI. You've got an encoder stack on the left that reads the sentence, and a decoder stack on the right that spits out the answer. But look closely. Notice what's missing? There are no loops, no sequential processing. At the heart of it all are these new blocks called multi-head attention. So how on earth does this thing work if it's not going word by word? Well, it all comes down to two incredibly clever ideas that work together in perfect harmony. Let's break them down. The first big trick is multi-head attention. Now, instead of having just one attention mechanism, the paper said let's run 8 of them at the same time, in parallel. It's like having a committee of 8 different experts all reading the same sentence at once. Maybe one expert is looking at how verbs connect to subjects, another is tracking pronouns, and a third is focused on adjectives. They all do their job at the exact same time, giving the model this rich, layered understanding of the sentence instantly. Okay, wait a minute. This leads to a huge question, doesn't it? If the model sees all the words at the same time, how does it know the difference between the dog chased the cat and the cat chased the dog? The meaning is totally different. And the answer is the second brilliant idea, positional encoding. It's so elegant. Before the words even go into the main part of the model, it adds a little piece of information to each one that describes its position. It's basically stamping each word with a numerical address. Your word number 1, your word number 2, and so on, using this really cool trick with sine and cosine waves. This gives the model all the word order context it needs without ever having to go one by one. So, you've got this wild new design that's completely parallel, but the real question is, did it actually work? Was it any good? Oh yeah, the results weren't just good, they were absolutely stunning. They completely reset the bar for what was even possible. Okay, here's the technical aha moment, but stick with me because this is the key. With the old models, connecting 2 words that were far apart took more and more steps. But with self-attention, the path is always constant. That's what that O1 means. It takes the exact same single step to connect any 2 words. Computationally, the first word of a book and the very last word are now direct neighbors. This was the breakthrough for understanding long-range context. And the proof was right there in the numbers. On a major translation test, the transformer hit a quality score of 28.4. Now, that number by itself might not mean much to you, but in the world of AI research, improving by even a tiny fraction of a point is a huge win. Jumping by over 2 full points, that's like shattering a world record.
And here is the real kicker. They got this new state-of-the-art result while training on just 8 GPUs for 3.5 days. That was a tiny fraction of the training cost of the models it beat. So it wasn't just better. It was unbelievably faster and more efficient. That efficiency is what blew the doors open for the truly massive AI models we see today.
So let's zoom out and connect the dots here. This wasn't just some academic paper that sat on a shelf. The ideas inside it, the transformer architecture, became the fundamental building block for pretty much all the AI tools that are changing our world right now. Seriously, every time you use ChatGPT, every time you use an advanced translation service, or generate an image from text, or get help writing code, you are using technology built directly on the foundation of the transformer. Yeah, that T in GPT, it stands for transformer. This paper is the engine behind it all. And that just leaves us with this one last thought. This whole AI revolution didn't start with more data or bigger computers. It started with a single, elegant new idea. It really makes you wonder, doesn't it? What's the next simple, radical idea out there, just hiding in plain sight, waiting to change the world all over again?